All right, this is the first of several exam review videos. This is part one, exploring data. This corresponds to chapters 1 and 2 that we covered at the very beginning of the year. Exploring data accounts for 20 to 30% of the material covered on the exam. Exploratory analysis of data makes use of graphical and numerical techniques to study patterns and departure from patterns. Emphasis should be placed on interpreting information from graphical and numerical displays and summaries. Chapters 1 and 2 is where we learned how to make graphs like histograms, dot plots, stem plots, and box plots. We learned how to describe distributions. We learned how to make sure we can calculate means, medians, standard deviations, and interquartile ranges. For the most part, that's with the calculator or those values are given. We learned how to compare distributions. It's also where we learned how to calculate z-scores and interpret them, and to work with normal distributions. Those two will be covered in the next video. That's chapter 3 and important on its own, so I'll make a separate video. You've got to ask yourself, do you still know how to make histograms, dot plots, stem plots, and box plots? Now, of course, you can use TI Inspire to make histograms, dot plots, and box plots. I'm sure that we're going to cover the physical aspect of putting data into the calculator and remembering how to make those three graphs over the next couple of weeks as we're doing sample problems. Stem plots, you cannot do those on the TI Inspire. You've got to know how to make those on your own and interpret them. So on the AP exam, in a free response setting, if they ask you to write a few sentences describing what you see in a graph, in order to get full credit on that part of the free response question, you must address 4 elements or you will not get full credit for that part. Remember that I taught you the mnemonic SUCS, S-U-C-S, to describe what you see in a graphical display. S is for shape, U for unusual, C for center, S for spread. Distributions can have skewed left, skewed right, symmetric or uniform shapes. Unusual features are gaps and outliers. And of course, we're going to make sure that you remember how to actually test for outliers. Center is mean or median, and spread is standard deviation or interquartile range. Yes, we'll make sure you still remember how to calculate an interquartile range. Standard deviation in this early stage is not something they're going to make you calculate by hand. It's more given to you and what does it tell you. So there are 4 key shapes, and really 3 of them are very important. Skewed left, skewed right, roughly symmetric, and uniform. So remember, uniform just means that the bar heights are roughly the same height. Now remember, when a distribution is skewed, it's the tail that tells you the direction of the skew. So when we're looking at this one, sorry about that, we see that the tail is going to the right. Here we see that the tail is going to the left. So just remember, the tail is the skew. This one is roughly symmetric, and we should remember those 3 basic shapes. Now, box plots can be a little bit more difficult to tell the shape. We went over this, and it's important that we go over it now. If the median of a box plot is roughly in the center of the box, that's usually when you would say roughly symmetric. It's not so much about the whiskers. One whisker can be a little longer than the other whisker and still be considered roughly symmetric if that median is fairly centered. So you see up here, we say that this distribution is skewed to the right because you see how the median is to the left in the box. So then what that means is we've got a lot of spread to the right of the median, and that's why it's skewed right. Skewed left, notice that the median is to the right in the box, and we've got lots of spread to the left of that median, and that's why we say it's skewed left. So make sure you're aware of that for your box plots. Unusual features. If you see a histogram, stem plot, or dot plot with a gap or possible outlier, make sure that you describe that gap and outlier as unusual features. Of course, we're going to go into outliers more in just a few seconds. The center of a distribution is either the median or the mean. Now remember, the center of a distribution is, you determine which one you want to use by the shape of the distribution. So here we see a skewed right distribution, and remember, in a skewed right distribution, the median will be somewhere near the high point, and the mean will be to the right of that. Remember that the mean is not resistant to skew. It always goes towards the skew. So when a distribution is skewed right, we know that the mean will be larger than the median. If a distribution is skewed left, we know that the mean is less than the median because the mean is pulled to the left in the direction of the skew. In a symmetric distribution, we know that the mean and median are roughly equal. Now, when a distribution is skewed, the median is the best measure of center. Do not report the mean. If a distribution is symmetric, the mean is the best measure of center, but of course the mean and the median are roughly equal. But if a distribution is symmetric, it's best to say that the center is described by the mean. Okay, the spread of a distribution. Remember that the spread of a distribution is dictated by which measure of center that you chose. If a distribution is roughly symmetric or uniform, as we discussed on the previous slide, the mean is the best, and the standard deviation pairs with the mean. If a distribution is skewed, the median and the interquartile range are paired together.